So another way that high groundwater is managed in an urban environment is through subsurface drainage. So this is putting drainage just below the surface around the houses, and then those pipes, that subsurface drainage, could be joined and discharged to the nearest stream. Problem with that is it really speeds up the time that it takes. So it makes very short the time that it takes for the water to infiltrate the ground and then reach the stream. When that travel time is really short, which would happen when you've got pipes, then there's no attenuation of nutrients. There's two things there. One, the travel time is really short, and also they're moving through pipes, not through soil. And so the soil is not doing any of its absorption of nutrients. So you put those two together, when you just have subsurface drainage going to a stream or a nearby creek, there is almost no attenuation of nutrients.
In order to control groundwater levels in the area, a system of subsoil pipe drainage are all across the development. Those pipes convey groundwater, intercepted groundwater, into this pit here and mix up with the total stormwater volume moving down the final treatment at the biofilter. We found that this, even the small rain garden system were quite efficient in removing particulate phosphorus and other pollutant, and also cleaning the water. So the water joining the main stormwater is actually free of sediment, clean water.
So the aim here is instead to infiltrate the water wherever you can across the development. It could be in the middle of the street, like in the rain gardens we saw earlier. It could be in a public open space. It could be in a children's playground, in areas where you can infiltrate the water. So the water spends as much time as possible underneath the ground, and therefore the nutrients are being absorbed before it goes to the downstream or the creek.